Today's lesson is on rates and ratios. So let's look at this scenario. The ratio of faculty members to students at a college is 1 to 15. There are 675 students. How many faculty members are there? Since they start out giving us a ratio here of 1 to 15, we're going to set that up as looking like a proportion. So if we set that up 1 to 15, 1 to 15. For our second proportion, we're going to see, now notice that when they said faculty members to students, since they mentioned faculty members first, that tells us that faculty members is the 1, and because they said students second, it's the bottom number. So you have to look at that. So when we set up our second ratio, there are 675 students. We have to put it on the bottom, just like in the first ratio, the students was on the bottom. So what that looks like is this. Faculty on top, students on the bottom. So 1 to 15, faculty to students. We don't know how many faculty to 675 students. Now we're going to solve it like we did yesterday with proportions, where we do our little butterfly wings. So on one side we have 675 times 1, which is just 675, and then 15x on the other side with the other wing. And then we divide both sides by 15, and it's going to tell us if there are 675 students, there are going to be 45 faculty. So it's using the proportions that we did in our last lesson with these rates and ratios. Let's look at another example. The ratio of games won to games lost for a baseball team is 3 to 2. The team won 18 games. How many games did the team lose? So again, if you read the first part, the ratio of the games won to games lost tells us that in the ratio, 3 is referring to the number won and 2 is referring to the number lost. So we're going to set it up like that. Won on top, lost on the bottom. 3 to 2. And then it said the team won 18 games. So we put that on the top because the top is where we're putting the victories. And the missing number is on the bottom. Now again, we do our proportions, so we do our butterfly wings. So on one side, we're going to have 18 times 2. On the other side, we're going to have 3 times x. And 2 times 18 divided by 3 would be 12 games. This person from Japan ate 53 5/10 hot dogs, which is 53 and a half hot dogs in 12 minutes to win a contest. I love the Coney Island hot dog contest. It's insane. Find the unit rate in hot dogs per minute. Round to the nearest hundredth. So again, if you read up here, hot dogs 2 minutes. It tells us that hot dogs is going to be on top and that the minutes are going to be on the bottom. So first it says they ate 53 and a half hot dogs in 12 minutes. So we set that up on one side. And on the other side, since it says what is the unit rate, for unit rate means we want to know how many hot dogs they ate in 1 minute. So here's the 12 minutes, here's the 1 minute. Now look what happens here. If you do your proportions in your butterfly wings, on one side you're going to have 53 and a half times 1. Well, that doesn't change 53 and a half because 53 and a half times 1 is just 53 and a half, and the other side is 12x. So all you're having to do is divide by 12. So essentially you're setting up like this, but when you think about it, you don't even really have to set up this side when you're finding unit rate. You just know that since you're doing a 1 here at the bottom, and because when you multiply these, this is 1, all you have to do is set up this ratio right here, and then divide. You're going to type into your calculator 53 and 5/10 divided by 12. And that would be for approximately, this sign right here means approximately, we're rounding to the nearest hundredth, 4 and 4600, so about 4.5 hot dogs per minute. That's about 1 every 15 seconds. That's disgusting. Okay, finding unit rate again. Unit rate means we want to find how much it was for 1 hour. If you look up here, it says Corey earns $52.50 in 7 hours. Unit rate means how much did he make per hour in 1 hour. Okay, so again, when we have money, anytime money is involved, money is going to be on top. If they had reworded this and said, in 7 hours, Corey earned $52.50, the money has to be on the top. Otherwise, you have on top whatever they mention first, but the money always has to go on top. Since it's unit rate, there's really no reason to put this side of the proportion because you're just going to be dividing by 7 anyway. So you take your calculator, you set up your ratio like this. Take your calculator, go $52.50 divided by 7, and we're going to round it to the nearest cent, $7.50 per hour. Okay, let's see how dimensional analysis will be used with this. A large adult male human has about 12 pints of blood. Use dimensional analysis to convert this quantity to gallons. So we have 12 pints. Now, in the conversion, we have to think about what, I'm going to back that up. We have 12 pints. We have to think about what conversions we know. We have a common conversion chart that you can print off. We know that there are 2 pints in a quart, and we know that there are 4 quarts in a gallon. So when we set this up, this is not like a proportion where you write an equal sign. With this, you're doing multiplication. So we write our 12 pints, and we know that there are 2 pints in 1 quart. If you remember from our lesson on dimensional analysis, the pints have to cancel out. So when you're writing this ratio over here to know what goes on top and what's on bottom, you make sure since pints is on top over here, pints has to go on the bottom here so that they cancel out. Then for our second one, to convert from pints to quarts, we know that to convert from quarts to gallons, 4 quarts into gallons, because their quarts are on top here, we have to put the quarts on the bottom here. 4 quarts equals 1 gallon. Now, this is not a proportion. This is not an equal sign. These are multiplication. So we're going to multiply everything on top. So we have 12 times 1 times 1 on top. And on the bottom, we have 2 times 4. I'm going to erase that just because it doesn't look very neat, and this looks neater. Same thing. Okay, so the pints cancel out. The quarts cancel out. You multiply everything on top. 12 times 1 times 1 is 12. On the bottom, you have 2 times 4, which is 8. And 12 divided by 8 would be 1 5/10, which is 1.5 gallons. We have a lot of confusion between proportions and dimensional analysis. Remember, with proportions, you have an equal sign, and you're doing the butterfly wings. With dimensional analysis, you have a multiplication sign, so you're just multiplying the numerators, every number on top, and multiplying every number on the bottom. Another dimensional analysis here. The dwarf seahorse, and I cannot read that scientific name, but you can see it there, swims at a rate of 52 6/800 feet per hour. Use dimensional analysis to convert this speed to inches per minute. So again, notice that we are converting from feet to inches, so we have a distance conversion, and we're converting hours to minutes, so we also have a time conversion. So let's write 52 6/800 feet per hour. There's the ratio we set up. Now we have to think first, what do we know about a conversion between feet and inches? We know that there are 12 inches in 1 foot, so we're going to put one of these on top, one on bottom. We want the feet to cancel out, so the feet has to go on the bottom, so we're going to put the 1 feet on the bottom and the 12 inches on the top. We've done the distance conversion. Now to do the time conversion, we're converting from hours to minutes. We know that there are 60 minutes in 1 hour. since hours is on the bottom, we have to put the hour on the top so that they can cancel out. And then we have 60 minutes. Now, since this is dimensional analysis and it's multiplication, we multiply everything on top together. And then we multiply everything on the bottom. So when you do that, I'm going to erase this because I have this on my PowerPoint slide looking a little neater. So here's this, the same thing. And if you take your calculator and multiply 52 and 6800ths times 12 and then divide by the 60, you're going to have about 10 and a half. 10 and 536 thousandths inches per minute. Okay, let's do one more of these. A cyclist travels 56 miles in 4 hours. We're going to set that up as a ratio. Convert his speed to feet per second and round to the nearest tenth. So we have the information here. What they say first we put on top. So we say 56 miles in 4 hours. We set that up as a ratio. Now we're ready to convert. We're converting from miles to feet. What do we know about feet and miles? We know there's 5 tomatoes, 5,280 feet in 1 mile. So when we set that up, since miles is on top, we have to put the miles on the bottom. 1 mile, that's not plural, that would be singular, is 5 tomatoes, 5,280 feet. Now we do our time conversion from hours to seconds. Now when we were talking about dimensional analysis a couple of lessons ago, we know that there are 60 seconds in a minute and 60 minutes in an hour, and 60 times 60 is 3,600. So we can use this 3,600 seconds in 1 hour, or you can do the 60 and 60. So let's see here. We have hours on the bottom. So 1 hour has to go on top, and 3,600 seconds goes on the bottom. Now again, I'm going to erase this just because my PowerPoint slide looks a little neater, but I was showing you how that works. So here it is, the same thing. Here it was done in 2 steps where we say 1 hour equals 60 minutes and 1 minute equals 60 seconds. We just did the shortcut where we had 1 hour equals 3,660 seconds. Either way, you're going to get the same answer. So now multiply everything on top together. Then you multiply everything on the bottom together. You do your division, and you get 20 and a half feet per second. Good luck.